Hi, welcome to question 6. So now let's do the part A, and you have to run the house's price on the dummy variable, which captures whether the houses are near the incinerator or not, and we have to filter the data, only look at the data which has a year equal to 1981. So this is the regression result, and the coefficients here is negative 30,000 plus, and is significant. Also for the intercept, you can see that it's significant. So what does it mean? This means that the houses that are near the incinerator in 1981 on average is $30,688.27 lower than the other houses. So what are the other houses? Other houses are those not near the incinerator. Okay, so the average price of the houses that are not near the incinerator is 100,000 plus. So in question B, you have to regress the house price on the near in, but this time filter the data to include only the data of year 1978 with the robust option, and you can argue in the same way as before. Just one thing to note here is that in 1981 the incinerator was already built, but in 1978 the incinerator was not built yet. So this is before the incinerator. Okay, and you can see that the average price of the houses that are in the incinerator region is 18,800 something lower than the average of the other houses. And other houses means what? Is the houses that are not near the incinerator region. Okay, so before the incinerator was built, you can see that there was already a price difference between the houses that are not in the incinerator region and the houses that are in the incinerator region. So that is part B. In part C, you are taking this value minus this value, right? So you have that minus this value. So what you get is roughly equal to 11,864 roughly. Okay, so what does it mean? You have a minus sign here. The problem with this is that you do not know the standard error, you only know the values, so you cannot do the hypothesis testing. Okay, since you cannot do the hypothesis testing, so it's not good. So you have to find another method to know the standard error for this value. Okay, so just follow the tutorial. There's instruction there. You just follow that, and after that we explain the coefficients, then we understand why the coefficients is this value. So what is this value anyway? So you can think of it this way. This value captures where the houses where they are near the incinerator, right? And then here is the different years. So you can think of this as the difference in the, or the change in the price of the houses that are in the incinerator region, okay, from 1978 to 1981. So you can think of it, or say it in a different way. You can say that after the incinerator is being built, the change in the average prices of the house that are near the incinerator is equal to this. Alright, so let's follow the instruction in the tutorial and run this regression. Okay, on to Y81. Y81 is over here, Okay, so the label kind of give you the insight into the variable, that it is a dummy variable. Okay, and then you have the introduction term, which is y81 near in, okay, which is here. That is the introduction term. You can put a robust option there. So the regression that you have is this. Alright, and you see that the difference between this coefficient and this coefficient is now captured here. Okay, why is that so? It's because you see that here, this one is where you have the introduction term. Okay, you may wonder why delta 1 captures the change of the house's housing price of the houses that are near the incinerator from 1978 to 1981. Well, you can think of this. You can think of it this way. So you are looking at the houses that are near the incinerator, right? So therefore, this value is equal to 1. And then you would have the value for y81 to be either 1 or 0. So if it is equal to 0, the whole term here is equal to 0. If it is 1, then it's 1, then you have this value, right? So that means that this delta here would captures the change in the prices of the houses that are near the incinerator from 1978 to 1981. Okay, that's it. And from this regression, you can see that the probability is very big. That is to say that the change in the price of the houses in the incinerator region from 78 to 81 is insignificant. So the change is insignificant. Okay, so let's move on, and you can discuss part D, where part D asks you to estimate the model. We have done that, and then interpret all the coefficients. So we have discussed delta 1, right? So let's look at the beta naught. So what is beta naught? Beta naught, in order to see what beta naught means, you can control this equal to 0, this is equal to 0, and this equal to 0. So what does it mean? It means here that you not looking at the year 1981, so it's the year 1978, and it is not near the incinerator. So that means that this beta naught captures the average price of the houses that are not near the incinerator in 1978. Okay, so that is beta naught. What about beta 1? Beta 1 is here. Okay, so beta 1 would measures the location effects, not due to the presence of the incinerator. So that means that it captures the effects of whether it is 1 or 0. Okay, so whether it is near incinerator or not near incinerator. Okay, so that is beta 1. And what about delta 0? Okay, so let's look at the delta 0. So in order to see delta 0, you can switch on or off the y81. Okay, that means that if it is 1981 or not. Okay, so this captures the changes in the values of all the homes from 1978 to 1981, because 1978 is 0, 1981 is 1. Alright, so that is part D. We have discussed this earlier. Okay, in part E, you have to include other explanatory variable into the regression above. Y81 here. Okay, so you have include whether it's near the distance to the interstate, and then the land area, the house area in feet square, the rooms, number of rooms, then number of bath, and the h, and the h square. Do we have the h square here? Yes, we have that. So with a robust option, and you run that, and what you find is that the coefficients of the interaction term now is higher in magnitude. Okay, it's more negative, and the standard error is even lower. So you know that the t-statistic in that case would increase, and you can see that the probability has decreased from 17% to just 3%. That means that now you cannot reject at a 5% confidence interval. So what does it mean? It means that you can reject and to say that this is significant. So that means that when you include other, when you control other for other explanatory variables, you can see that the interaction terms is significant. So what does it mean? The interaction terms, just now we have said that it captures the change of the average prices of the houses that are near the incinerator region from 1978 to 1981, right? That is whether the presence of the incinerator has any impact to the average price of the houses in this region. And you can see now that instead of insignificant, it is significant when you control for other things. Alright, so that is all for question 6. Thank you very much.